Can you hear me? I think most of you already here. We can start now. Okay, by the way, just checking, can you hear me? Okay, Melin, thank you. So let's start. I think we stop at tutorial 3, question 3. Okay, let's continue on question 4 onward. Okay, question number 4, tutorial 3. You are standing on the ground in full sun. Full sun is mean that solar lunar. Okay, the wattmeter hooked at your panel show a reading of 3.45 watt. If you got on a 20 feet roof and kept the solar panel pointed toward full sun, what might you expect the voltage reading to be? What's the difference between on the ground and on a 20 feet roof? What do you think will be the any different on that? Okay, so let's talk about in terms of height. How the voltmeter change with the solar irradiance? Okay, so maybe I show you the lecture note. Okay, this is the IV curve at the different solar irradiance. Okay, so it means that when the solar irradiance increase, the current will increase, but the voltage will almost remain the same. Can you see that? It's almost the same. So remember that when we have the increase in the solar irradiance, the power increase because of the increase in the current, but not increase in the voltage. Okay, so for this question, when you get closer to the sun, do you think you'll get a more solar irradiance? But remember that the distance between the sun and the earth is so long, and even the length of the atmosphere is about 50 kilometers. So this 20 feet is definitely means nothing. Okay, so I would not think that it will change the reading on the wattmeter in terms of solar irradiance, because 20 feet definitely will not have any changes. But if you consider something like shadow, then possible. You go to the rooftop, normally you get less shadow. Okay, but that one is unknown because not stated clearly. Okay, so in that case, you may consider as your own assumption. If there is no anything blocking for both ground on 20 feet rooftop, then the voltmeter should have the same reading. Okay, but if go up to the roof and then you get no shadow, then you should expect the higher voltage. Okay. Okay. I think very direct on this question. We don't need to have much explanation on that. So let's continue with question number 5. You are in Omaha, United States, and it is 9:30 in the morning. In what direction will you point your solar panel to get most energy? So you are now in this Omaha. So today is 26th of August. Okay. So and now it's 9:30 in the morning. So 9:30 a.m. Just to make it short, we consider this as a local solar time. Okay. So in what direction will you point your panel to get most of the energy? So in that case, you need to consider the solar altitude angle and solar azimuth angle. Okay. They will ask you in the different way, but the final idea is still get the direction of the sunlight so that you can get most of the power output. Okay. You may start answer the question. Okay, so 9:30 a.m. and 26th of August. So first you need to find the declination angle. Okay, and then of course we need to know the end. So on 26th of August, what is the end? Two three eight. Okay. So based on this rule, 238, we can get the declination angle. Okay, so our declination angle is 9.966 degree. Okay, then the next step, we also need to find the hour angle. Okay, but hour angle is very direct forward. So for this question, there's 9:30 in the morning. But remember this, it's not always local solar time. If not stated, you should consider this as a local time. Okay, unless stated this is a solar time, then you can take it as a RST. But now, because we just want to save time on the during the conversion, then I do it this way. Okay, but do not do that in the exam as well. You must find the local solar time. You need to convert from local time to local solar time. Okay, keep in mind on that. So if this 9:30 is the local solar time, okay, so how we calculate the H? So 9:30 minus 12 multiply 15 degree. Okay, so we get 37.5 negative value. And then once we get the H value, we should be able to get the alpha. So the latitude here is 41.2565. GA, are you sure? 0.7 only? I think you haven't act sign. Okay, because this is a sine alpha. Okay, so we get 44.55 degree. Okay, so from here we should be able to get the tilt angle of the panel. Let's say this is ground 44.55. So the panel should be tilted at the angle B, which is a 90 minus 44.55. Okay, so now we get the tilted angle, and then secondly, we need to get the direction. Then direction we should refer to the azimuth angle. Negative 57.28. Okay, so again, you need to draw the direction. North, east, west. Okay, this negative 57.28 is in which quadrant? So we have to compare the value of the latitude and the declination angle. So for this case, latitude is 41.2565. So it means that the sun definitely passed through the south of the Omaha. Okay, because the declination angle is up to 23.45 north only. But this location is even north. Okay, so you are standing on the Omaha, supposedly the sun will pass through your south. Okay, so we know that it will go through south and it is in the morning, so at the east side. Okay, so this is location of the sun and give the angle 57.28 degree. Okay, and for this case, we need to put our panel like this and pointed to the direction of the sun. Okay, you can draw or you can explain. So the panel must face to the southeast direction with the angle 57.28 from the south. Okay. Can follow? Shall we move to the next question? Okay, good, thank you. So let's look on the question number 6. This is to check your understanding. Let's say this is a rooftop of Block M, and we are going to install a solar panel on the roof. Block M, I think you know our FOET office, Block M. Tell where would you put them and explain why. Also explain what other things we would need so that the college would actually use the electricity produced by the solar. Okay, so let's say this is Block M, and let's draw a little bit. It's not too clear. You can see that this is the rooftop. Something like this. This is a rooftop of Block M. Okay. And then let's say these have the 6 location given: 1, 2, 3, 4, 5, and 6. And you only want to uh, use one panel. Let's say you want to use a panel for power up some devices. So you don't need to fully occupy the rooftop. Can you explain which part you will put the panel? At which point? 1, 2, 3, 4, 5, or 6? Do you understand the symbol over here? This is a compass. Huh? So the compass, the red direction is the north. Think about it based on your understanding on the block M tile you see, which point you will put the panel. So what to avoid? You must make sure that the panel face to the direction with the most sunlight. Okay. Secondly, you must make sure there's no shadow. It is possible to block the panel. Okay. Direction is actually the second choice. First, you need to consider make sure that no shadow blocking the panel, or else definitely your output will be very, very low. Okay, so what's your answer? 1, 2, 3, 4, 5, 6. There's no correct or wrong answer, but you need to justify your answer. You can choose 1, you can choose 6, you can choose 4, 3, 5. Up to you. As long as your justification is makes sense and acceptable. Okay, anyone have any idea where you would put your solar panel? There's no right or wrong, just explain according to what you understand. Number 5. Okay, so maybe we separate into 1, 2, 3, and 4, 5, 6. 1, 2, 3 is one pack, and 4, 5, 6 one pack. So we need to do the elimination first. Okay, so this is a tile UC block M, so the coordinate should be around 3 degrees north. Okay, so it means that we are located at the north hemisphere. So in other words, our angle, our direction of panel should face to the south. Okay, slightly to the south. Okay, so I would say 4, 5, 6 is good because 1, 2, 3 will face to the north and 4, 5, 6 will face to the south. Okay, then we look on the 4, 5, 6. Would it be any point which have the possibility blocked by a building or blocked by a tree? Okay, so the sunlight will mostly pass through the south. Not say mostly lah, 60% will pass through the south, 40% will pass through the north. But I think if pass through the north, definitely no problem. But pass through the south, you can see that we have 3 over here. Okay, I'm not really sure how tall is the tree, whether it's able to block the building or not. And then we have the Dermaculia over here, DKA. Okay, and there's possibility that DKA will block 0.4 maybe. Okay, and then these 3 also have the possibility to block 4, 5, 6. But this is up to your judgment. You may see that, oh, the tree is not too high. lower than the rooftop, so it won't block the panel. I think yes, because this is actually 3-story building. I don't think the tree is higher than the building. Okay, so that case, 3 we no need to consider. But DKA seem like quite high as well, so possible to block 4. So I think 5 or 6 quite safe. Okay, so just explain according to what you want, but remember that you need to consider the direction and the schedule. These are 2 things that we always consider. Okay, and then the next one. Okay, yeah, so we choose 5 or 6. So GA answer okay. We choose 5 and let's just explain. And secondly, also explain what are the things we would need so that the college could actually use the electricity produced by the solar. Any idea? What kind of the power come up from this panel? So you put the panel will give you the DC current. Okay, so how you want to use it by our college, by our institution? So you need to have a inverter because most of our electricity usage actually in the AC. So you need the inverter. Okay, how about battery? Battery is very optional. If you directly tap to the grid, then we don't need the battery. Okay, there's inverter is a must lah to convert from DC to AC current. Okay, battery lah, the meter lah, all is not a compulsory item. And then the charge controller also same thing. You need the charge controller only when you have the battery. So if here you have the inverter, then okay, good enough. The inverter will convert to the 220 watt or 240 watt, which is suitable for our grid. Okay, so what other we need is just a inverter. Must have lah. If you want to put the battery, okay lah. It's an option of battery. Okay. Okay, no issue because here is a car park, so I don't think anything the car park will block the point as well. So only possibility is DKA. Okay, let's move to the next point. Same thing, this is a school. Let you judge on your own, A, B, C, D, E. Okay, I give you the coordinate. Wait a minute. We use Google Map. Okay, I think in this school. Okay, I think if you look here, it will be clearer. Okay. And then the coordinate is given on the URL, 41 degree north. And you can see that I put negative. For the longitude, you put negative. Negative means that to the west. Positive is to the east. Okay, same thing for the latitude. If positive, it means north. If negative, it means south. But some of the case, they will use north and south. If you cannot say north and south, they will use positive and negative. Okay, so now you come back to this question. Point A, B, C, D, E. Which point you think would be possible to put a panel? Same thing. This area must be, okay, now you no need to consider the direction, the angle. The angle must be just pointed to the angle that you need because all you put on the ground is a flat ground. Okay, so now which you have to consider is shadow. Any possible shadow block on this point. Okay, just look on this graph. If you 1 minute to think about it. Okay, so let's come back here. So same thing, the Google Map will automatically pointed to the north on top. Okay, unless you rotate it. Okay, so let's come back to the tutorial question. Okay, so to the this is north. Okay, so this is east and west, and the location is 41 degree north. Okay, so it means that the sun will pass through the south all the time. Okay, so the sun will go to east to west from south of the location every day, just on different angle. So you need to consider, make sure that the shadow will not fall on that point that you pick. Okay, for example, let's say the sun pass through from east to west. So it means that on the north, it passed through the south from east to west. So it means that you cannot put a panel which is here, because this is the north of the panel. Definitely the shadow will fall on it. Okay, so this one definitely cannot. So how about point D? Because the sunlight, you can see that the path of the movement of the sun. Yes, there is a possibility at the afternoon or evening. This point D will blocked by the shadow of the building here. Okay, so I would say point D out, definitely out. Of course, there's a very big area, but I think the building is not too short. Okay, so it's possible to block the point D. How about point E? I think point E is quite safe. You look on the direction of the movement of this sun, nothing will block on point E. Okay, so point E is good. And point ABC, point ABC, they are quite close to the tree. This tree, but I don't know how tall is the tree. Okay, so in the real case, you need to know that what is the size of the tree, how tall is the tree, and what is the length of the shadow will extend. Okay, so that you can judge properly. As long as you know the angle of the sun, you okay, then you should be able to judge the shadow length. Okay, but how we measure the length of the tree, how tall is the tree? Then we always have the method, okay, to estimate. Of course, we do not need to climb up the tree to measure the length. Okay, but that method I will explain here lah, because this out of the topic already. But definitely we have the method. We know the direction, we know the distance between the tree and me, then I actually can measure the how tall is the tree. Okay, maybe something like this lah. Yeah, easy. Let's say this is a tree. Okay, this is a ground. This is a tree, and then I put a length of the object over here, maybe 1 meter length of the object. Okay, and then I find a location, a point, which will have the tip of the ruler over here. At the tip of the tree is the same line. See that? So that based on the angle, distance, I know the distance here, distance A. I know this length B. This is what I know. I know distance C. Okay, so based on A and B, I will know the angle alpha. Okay, based on the alpha and the length C plus A, I will know the height of the tree, maybe D. Okay, these are the way by mathematics lah. But how accurate you measure in this way is very subjective lah. Okay, you look at the tip, and tip must be the same line as the ground. Okay, ideal case but I think won't run too much lah. Okay, so point ABC try to avoid lah, because we do not know the height of the tree. If you already know the height of the tree, then you can justify which point can be used to build the panel. But now I think point E is quite the best point. Yes, definitely you can see that point E, there's a tree at the back. But we don't care what the tree shadow will fall to the north side. Definitely, it will never fall to the south of the tree. Okay, so doesn't mean that it grows to the tree we have to cut it. It's still okay as long as the shadow will not fall in it. That's why we need to check the direction of the sun. Okay. Okay, let's move to the next one. Okay, if the temperature in July was 88 degree and solar panel produced 45 watt, what would you expect the voltage to be on the 30-degree day? Okay, 88 degree and 30 degree in December. If the solar panel received the same amount of sun on both days, so it means that solar irradiance is the same. The only difference is the degree temperature. But this one, 88 degree, I think is not degree Celsius, but it should be the Fahrenheit. Okay. Okay. So how we do this question? Okay lah. Maybe we change the angle lah, we change the degree so that we don't need to do the conversion. Let's say 35 degree Celsius, and this one let's say -5 degrees Celsius. That's it lah. Okay. So now the temperature in July, which is in the summer, is 35 degrees Celsius. And now in December, which is winter, which is a -5 degrees Celsius. And what would you expect on the change in the voltage? Okay. So let's go to this curve, IV curve. We see how it changed accordingly to the temperature. You notice that when the temperature increase, the voltage will drop. Okay, it's based on this line. When the temperature increase, voltage will drop. Okay, so it means that when temperature drop, the voltage will increase. Okay, first thing we know that the voltage will definitely increase. But they ask for voltage. How much the voltage? Then you need to refer to the specification of the solar panel. Okay, for example, let's say we use the solar panel that we use in the lecture note. The spec. Yeah, let's say this one. Okay, and then we ask for the voltage. Produce 45 watt. Okay, and then this one is of course didn't state clearly whether it's open circuit voltage or the maximum power point voltage. But normally we take it maximum power point voltage because open circuit voltage actually do not have any special meaning. You cannot use it. It's just for your something like one of the characteristic. Okay, we are not able to use that because once you connect to the load, then the voltage will drop already. So we expect this is the maximum power point voltage. Okay, where is it? So the temperature coefficient is -0.41% per degree Celsius. Okay, so it means that okay, you check here, temperature coefficient -0.41, but this one is on the power P max. But what happened to the I and V? Okay, we know that power equal to I times V. And now the coefficient, temperature coefficient given is only for P. But how we differentiate between I and P? Then we go back to this graph. You see that the effect of temperature on the current is very minimal. Okay, but the effect on voltage is very huge comparatively. So you would say that we always consider, if not given properly, we always consider the temperature coefficient for the power will be equivalent to the temperature coefficient for the voltage, because the effect on the current is low. Okay, so it means that when the temperature increase by 1 degree Celsius, the voltage will drop by 0.41%. So this is about 40 degrees Celsius. Okay, so 40 degrees Celsius multiply negative 0.41%. I would expect the drop of 16.4%. Okay, so 45 degree, it's not decreased by negative 16.4 is positive because you can see that we from high temperature to low temperature. Okay, so it should be negative 40. Temperature change is negative 40. So we get positive 16.4. So you just 45 times plus this 16.4%. Okay, then I get the voltage is 52.38 degrees Celsius. Sorry, not degrees Celsius, it's a voltage. Okay, so we can, based on the temperature, estimate the voltage out. No question, we're direct forward. Then we move to the question number 9. If you live in the Santiago, which is located at 33 degrees south latitude, what position and angle would you set the panel to in summer? So you can see that sometimes I give you time, sometimes I don't give you time, sometimes I give you date, sometimes I don't give you date. So this is a real time, a real case situation. Your customer, the consumer will not always give you enough information. You won't tell. You don't expect them to give you the complete information to do the calculation. Okay, so there's still a lot of information that we need to do our own assumption. For example, for this case, they want to use in summer only. This is their consideration. So how you want to set the panel? Maybe in the summer they have more activity, need extra electricity. I don't know, but now they just consider on the summer. Okay, so first you need to know what is the date when this location Santiago have the summer. Okay, so same thing. I have to draw north, south, equator. Okay, and location of this Santiago is 33 degrees south. Maybe I pointed here. And the angle is 33 degrees. Okay, this location is Santiago. So the next step, I need to know the movement of the sun. As we know that the sun will move away from the equator by 23.45 degrees, and same thing to the north and to the south. So that I know that movement of the sun is like this. Okay, so this is a path of the movement is 23.45 degree north and south. Now I need to justify which is when the sun, okay, now you want the summer on the Santiago. Summer, why you have the summer? Because the sun is closer to that location. Okay, so when the sun is located on the sign to the south hemisphere will have the summer. When the sun shine to the north hemisphere will have the summer, and the opposite side should have the winter. So in that case, because we want to set the panel in the summer, it means that the sun is located at the south hemisphere, which will give the summer to the south hemisphere and winter to the north hemisphere. Okay, then what's the date here? Okay, when is the date when you have the sun is at the south hemisphere? Okay, so this one you have to find a reason how to remember lah. Okay, so for example, normally we are more familiar with the north hemisphere, United States lah, Europe lah, China lah, all located at the south hemisphere. Sorry, all located at the north hemisphere. Okay, So for that case, when they have the summer and when they have the winter, we know that they always have the winter at the end of the year. Okay, and summer always in the mid of the year. So summer is mean June 21. So December 21. And here we have March and September. Okay, so it's mean that now we already identified the date, which is December, around December. So what is the altitude angle, declination angle here? So we get the declination angle, negative 23.45 degree, which gives the summer to the sun triangle. Okay, so what else we need? We need the latitude. Okay, latitude fine, we already have it, 33 degree south. And we want to know the direction exactly, then we need to know the angle, altitude angle, and azimuth angle. Okay, but to get the altitude angle, you still need the hour angle. What is the hour angle that you need to set? Anyone? The time is not given. Remember the hour angle is affected by the time only. So if the time is not given, what should you do? Anyone? What do you think? Time is not given, so what should you do? Okay, so whenever time is not given, we should point the panel to where there is most sunlight. So it should be the solar noon. Okay, so the hour angle at solar noon will be 0 degree. Okay, so this is the solar noon. If the time is not given, we always pointed to the solar noon to get most of the sunlight. And this is also the middle point of the movement path of this sun. Okay, now we have all the angle that we have, then we should able to calculate the alpha. One, we have alpha. Okay, wait. I think we can first decide face to the north or south. What do you think? The panel must face to the north or south? North. Okay, definitely you have to point it to north because Santiago is on the very south. So you are pointed to north. Okay, so it's mean that answer A and B out. Then we just look on the degree. Okay, so degree we have to refer to this one. Do I need to still calculate azimuth angle? Because we use solar noon, so that definitely at 0. So whether face to north or south. So we already decide we have to face to north. Okay, so next is to get the alpha, then end of story. Plus cos L, cos the Greenwich angle, cos our angle. Okay. Okay, this is a 33-degree south. So it means that when you substitute into the equation, you have to use the negative 33. Yeah, actually, I think you put positive. $79.95. Okay. Okay. So now you get the alpha. So of course we need to get the tilted angle. So tilted angle should be 90 degree minus 79.95. Okay. So we get around 10.05 degree. So the bar band should tilted around 10 degree is the best. Okay. So the closest answer is D. Of course, they will not have any objective question in the exam. Okay. Any question at this point? We have completed tutorial 3. If no question, then I think we can move to tutorial 4. Wait a minute. Okay. Can I tutorial 3? No issue. Then we move to tutorial 4. Okay, let's have a look on the first question. This is an exam standard question. Maybe you read through it, see how much you understand. If you can answer this question, definitely you are able to answer uh, exam question, similar standard. Okay, a building owner want to place a PV module flat on his rooftop. Okay, to power a sign 12 hours each night. So maybe this is a shop lah. So they want to power the sign. Okay, for 12 hours each night that draw 500 watt. And if a PV module generates 16 watt square feet, if the module able to generate 16 watt per square feet at the peak irradiance, peak irradiance means that 1000 watt per square meter, and the worst case month average irradiance is 2.4 peak sun hour. So it means that the worst case, the peak sun hour. Okay, so let's do a little bit revision on the peak sun hour. Okay, this is the calculation of the peak sun hour. Okay, so it means that how many hours of the sunlight you have, which have the solar irradiance of 1000 watt per square meter, and this can be accumulated. So for example, from 7 to 8 a.m. in the morning, the solar irradiance is 150 watt per square meter. So in that case, in this hour, I get 0.15 peak sun hour. Okay, 8 to 9, I get 250, 0.125. 9 to 10, I get 0.4. And I total up for the entire day, there is a big total peak sun hour for this day. Okay, this is what we mean by the peak sun hour. And for this case, it gives you that the worst case you also can get 2.4 peak sun hour per day in one day. So we always take the worst case as the estimation because you don't want your park sign sometimes have not enough power. So you want to make sure that it's keep having enough power. So you have to use the worst case estimation, okay, which equivalent to 2.4 peak sun hour. And what is the minimum square feet of PV module required? And then you have to assume that the charge control efficiency is 95%, and the loss factor for the remaining system is 80%. So definitely you need a battery, because you can see that you have charge controller. Charge controller is just for the battery, okay? And then the efficiency 95, and then the loss factor for the remaining system is 80%. So first thing, you need to, you need to calculate the required power. How many power required for the system, or how many power you need? Okay, power requirement is how much? 500 watt. Okay, but this is just per time because you have battery, so it means that you can store the energy. So you need to consider how much energy you need in one day, total energy. Okay, so I put energy required should be 500 watt times with the time I need to operate the sign. So for this case, I need to operate the sign for 12 hours. Okay, so times 12 hours, then I get 6,000 watt hour. Okay, so it means that in one day I need to use 6,000 watt hour of energy just to power the sun. Okay, then we calculate per square feet. How many how many energy the panel can generate in one day? Okay, this per square feet calculation. Square feet. Okay, so energy generated is able to generate 16 watt per square feet if the solar irradiance is 1,000 watt per square meter. And in one day, the worst case, you will have the 2.4 peak sun hour. Okay, so from here you will get the watt hour. But this is only the power generated by the panel, and you need to charge into the battery through the solar charge control. We have the efficiency of 95%. So 5% of the energy loss. So multiply with 0.95. And then they still have other system losses, something like mesh loss or the dust loss where the dust cover the panel, get the less output, and then mismatch due to some any shadow or anything, bird fly through the panel or bird stop on the panel that block the output. So we consider another losses of 20%, which is the efficiency of 80% given by the question. Okay, then we always able to calculate how much power, how much energy can be generated. Oh, so fast here, thank you. 29.184 watt hour per square feet. Okay, so very direct forward. This is the required energy to power the sign, 6,000 watt hour. And this is the energy you can generate in one day by 1 square feet of panel. So definitely you're able to calculate the area. Okay, energy required divided by energy generated per square feet. Okay, so then you can get the area, 6,000 divided by 29.184. So 205.59 square feet. Okay, do I need to round up or round down? Not needed, because this is the calculation is everything on square feet. 1 square feet doesn't mean 1 pieces. Okay, so we just give the square feet will do. But if the question gives you the size of the PV module, then it asks you how many pieces of PV module you can use. Then you cannot left the answer in the decimal point, because cannot be 2.5 pieces. Must be exactly 1 pieces, 2 pieces, 3 pieces. Okay. Can at this exam standard that you can understand this, then should be no problem. Okay, I think we'll stop at this question and we'll continue the other question next time. Okay, so any question until question 1 to 4? Can I follow? No response. It means no issue. Huh? Your group is very quiet. Huh? Okay, thank you. Jie is the best. Always respond to me. Okay, thank you so much, Jie. And then if there's no other question, then there will be all for today. Thank you for your time. Okay, and thank you. Bye.